We're going to look at a rotating disc that gets a clay ball dropped on it, and then they rotate together. So this is a type of collision where angular momentum is conserved. In order for angular momentum to be conserved, there can be no net external torques. And so my disc is free to rotate on a central axis, and I drop the mass on. So since it's free to rotate, we have no net torques external. And with no net external torques, momentum can be conserved. So all I need to do is I need to say, well, what was the momentum I started with? And find out the momentum I end with. Now, in this case, you might look and you say, I got 8 variables. Well, some of those variables are going to stay the same. Some of them are going to be the same as other ones. So we're going to narrow it down here. So anything going to be 0 to start with? Well, my clay ball is originally not rotating, so I'm not going to have an omega 2. Okay. I do have a disk, so my I1 for a disk is going to be 1/2 the mass times the radius squared times the original omega. Now, when I drop this ball on here, it's going to stick, and they're going to rotate together. So that means that these two values are going to be the same. Okay, so I'm just going to make that on that side I1 plus I2 times omega. And I use I1 here because my disk didn't change. It's still that 1/2 times 3 times r squared. All right, so let's kind of go ahead and figure out what my I value is going to be for this ball of clay. Now you might say, oh, a ball, that's a solid sphere. Because the object is landing way out here, I can consider it a point mass at a radius of r over 2. And so for a point mass, it's mr squared, and so my r is r over 2. So let's start putting in some stuff here. So I have 1/2 times 3r squared times my omega, which was originally 5. I'm going to divide these two over, so I have I1, which is going to be 1/2 times 3r squared, plus this one, which is going to be the other mass, 1.5 times r over 2 squared. And we'll find omega this way. So some things that are going to cancel for me. So my r squareds cancel. All right. This is 1/2 times 1/2, so I can get rid of one of my halves. And so I'm left here, I have 15 on top divided by 3 plus 1.5 divided by 2. When we put this all together, we find out that the final angular velocity is 4 radians per second.